Dear students, hope you are in good health. Welcome back to the 12th class of Advanced Computer Organization and Architecture. Here I am Aisha Siddiqa, Assistant Professor, Department of CSC. Today we will learn about multi-core processor. But you already submitted your case study on the history of single-core processor to multi-core processor. That means you already know lots of information about multi-core processors. Here we just discuss about the very basic information of multi-core processor. This is simply a circuit of multi-core processors. Let's know some history of multi-core processors. In the early 1970s, the first microprocessor was developed by Intel. It was a 4-bit machine that was named the 4004. The 4004 was followed by Intel's 8008 and 8080, as well as Motorola's 6800 and 68000. In every new generation of processors, there were several developments such as smaller size, faster, increased heat dissipation, greater consumption of power, etc. Let's know about the performance of single core. One technique used to increase single core performance was pipelining, that you already know from the chapter of pipelining architecture. In this technique, beginning other were waiting instructions before the first finished. And the another technique was multi-threading. Multi-threading involves execution of two separate threads. Time is divided and interlaced between the two threads in order to simulate simulations executions. Problems with single core. To execute the tasks faster, you must increase the clock time. Increasing clock time too high drastically increases power consumptions and heat dissipations to extremely high levels, making the processor inefficient. The problem of single core is solved by the multi-core. Creating two cores or more on the same die increases processing power while keeping clock speed at an efficient level. A processor with two cores running at efficient clock speed can process instructions with similar speed to a single core processor running at which the clock speed. Yet the dual core processor would still consume less energy. Advantages of multi-core. While working with many threads, a multi-core processor with n cores can execute n threads simultaneously by assigning a core to each thread. If it must process more than n threads, say x, it can apply multi-threading procedure with each core working with an average of x divided by n threads. A single core processor must multi-thread with every single thread. Here are some other intensive of multi-core. Improving an existing single core design or creating a better one is problematic in that it is time consuming to design, it risky to modify existing designs. Creating multi-core processors is convenient in that the name core dual and similar names are good for marketing. It has lower manufacturing cost, uses proven processor designs. Implementations of multi-core. Two main ways to have multiple cores interact are the shared memory model and the distributed memory model. In the shared memory model, all cores share the same cache memory. In the distributed memory model, each core has its own cache memory. The Intel Core DUO design has a separate L1 cache memory for each core, but both cores share an L2 cache. The AMD Athlon 64-2 implementation has separate L1 and L2 cache memory for each core. Some of the current problems found with multi-core processors like memory or cache coherence. As mentioned earlier, some implementations have distributed L1 caches but must share an L2 caches. This poses the problem of making sure each core keeps the other updated with change in the data in its own cache. Multithreading is also a problem when the software being run is not designed to take advantages of the multi-core processor. This may mean that one core does most of the work, which means that the processor is running no more efficiently than a single core. Future of multi-core. Current debates argue over whether future multi-core processor should be homogeneous or heterogeneous. That is, should all the cores be the same or should there be a mix of different types? Having all cores be the same makes productions easier and keeps its complexity to a minimum. Having different cores that are specialized in specific tasks increases complexity but has the potential to be much more efficient in speed and power consumption. That's all for today. Have a safe life. Thank you.